The Seabioplas project is a European Commission Framework 7 project under the Research for Benefit of SMEs scheme. Global society needs plastics. Europe produced 49.2 million tonnes of plastics in 2012, with the majority being used in the packaging sector. Production of plastics puts a strain on our already depleting fossil fuel resources. It also impacts on the environment in terms of recyclability and biodegradability. There is a need for increased production of biomass-based, biodegradable plastics in order to achieve the EU 2020 target of 10% of market plastics being bioplastics. Polylactic acid will be one of the leading contributors to bioplastic growth. PLA was the most produced biodegradable biopolymer in Europe in 2010. It is a sustainable alternative to petroplastics and is compostable and biodegradable. Seabioplas is developing a greener alternative to petrochemically produced plastics using PLA. Controlled cultivation of seaweeds allows for high traceability, management of biomass composition and properties, high quality and sustainability. Sustainability is further increased when cultivation of seaweed is carried out in integrated multi-trophic aquaculture systems. IMTA systems work by incorporating the waste products produced by one species into the diet of another species. Seaweed is able to utilise excess nutrients from aquaculture in the surrounding area. As well as the benefits of seaweed in IMTA, it also has several advantages over using the raw materials currently used in biomass-based plastics, including it contributes to the reduction of CO2 emissions, there's no competition with other industries for land use, higher productivities, reduction of nutrient input in marine coastal areas, no risks of reduction in biodiversity, no risk of potential deforestation, no freshwater consumption, and no fertilizers or pesticides used. After the sustainably grown seaweed has been processed to produce lactic acid, the precursor to PLA, seaweed residues will be generated. These byproducts have potential market value in themselves in the animal feed sector and can also be used as ingredients or supplements. In terms of IMTA cultivation of seaweed for plastics, the approach of using a tuned IMTA system was used to achieve the IMTA goals of cultivating seaweed for bioplastics. The Seabioplas project utilised ulva, Gracilaria and Alaria as the macroalgae species. The seaweed biomass in Seabioplas was produced under IMTA conditions, meaning that the seawater used for the algae culture was nutrient enriched, in this case due to the integration of the seaweed growing with fish farms. Another aspect of the Seabioplas project was examining pre-treatment and hydrolysis methods in advance of any further processing. Depending on the seaweed and on the application, milling, drying or freezing may be needed. Also, chemical pre-treatments may improve the functional properties of the extracts.
In the scope of Seabioplas project, we have optimized seaweed's hydrocolloids traditional extraction process for the seaweeds involved. However, traditional extraction is a tedious process, requires higher water and energy consumptions, and generates large amounts of wastes. Therefore, we are also addressing alternative energy forms, aiming at improved sustainability, efficiency, and environmental performance of the extraction process.
Lactic acid is a naturally occurring organic acid, which is produced by sugar fermentation by several microorganisms. In Seabioplas, the use of seaweeds as feedstock for the fermentative production of lactic acid has been studied at Food and Bio-Based Products, part of Wageningen University. In the current project, CEMAR carried out several fish trials, testing the effects of dietary seaweed and their extracts and their supplementation in marine fish. We observed positive effects on the immune and antioxidant responses in European sea bass and gilt-head sea bream. Such results indicate that seaweed supplementation may promote an increased resistance to infectious diseases and may improve fish welfare. Also, as part of the Seabioplas project, cattle feed trial supplementation took place. These trials were aimed at testing the mycotoxin binding properties of seaweeds in feed for dairy cattle. In specific terms, the action of seaweed as an aflatoxin binder and as a support for the animal's health and welfare was tested. After 1 month of administration, a decrease of M1 aflatoxin in milk from 17 parts per thousand to 6 parts per thousand was registered. By 2 weeks post-ULVA administration, M1 stabilised at approximately 10 parts per thousand. No significant variations in milk quality were registered.
Emerging or possible applications of the seaweeds includes the production of bioplastics. In Seabioplas, we tested several seaweed-based bioplastic formulations. We have been able to tune the plastic formulations in terms of color, mechanical properties and water solubility towards different bioplastics applications.
Polylactic acid, PLA plastics, are one of the most appealing groups of bio-based plastics. They are 100% renewable, compostable, and combine high stiffness with high gloss and transparency. Funded by the Framework 7 programme of the European Commission, Seabioplas was a highly collaborative research project with excellent results for future study and industrial exploitation by the SME industrial organisations and their research partners.